Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion. We're going to be talking about the major storm system that will be impacting the area on Friday into Saturday, as well as speculate on the potential for a more wintry event in the form of snow sometime in the next Tuesday into Wednesday period. So we'll first get started by looking at the current infrared satellite. And we see the large storm is approaching the area with lots of high clouds streaming out ahead of the parent system in the Tennessee Valley and Arklatex. It brought some moderate to heavy snow in parts of Minnesota already, in association with also an Arctic cold front moving through as well. And when you have this storm system with plenty of moisture streaming up from the Gulf into the Northeast, combining with an Arctic front, you get a big temperature and moisture gradient, and thus you can get a large, expansive storm system. But with all this moisture streaming out ahead of the system, as well as warm air advection on top of the snowpack that we have, that is a classic recipe for fog, and any fog that has formed will continue to get more dense throughout the rest of tonight and the overnight. And there may be some rain as well in the overnight, though most of the rain will be falling tomorrow. This is a look at the NAM models, precipitable water analysis. We always like to look at the precipitable water when we're potentially classifying heavy rain in the atmosphere. The higher the precipitable water, the more moisture content there is in the atmosphere. The analogy is if the atmosphere were to be a wet towel and you were to squeeze it, how much water would come out? So if there is a higher inherent amount of water in the atmosphere, that leads to a higher likelihood of heavy rain. And we can see that right now there are some higher precipitable water values being advected into the Northeast, though the core of the higher precipitable water values remain more so in the Ohio Valley and the Appalachians and Adirondacks. So, and this remains true throughout the overnight. Now I'm at 1 a.m., 2 a.m. Friday morning. The moisture content does increase in the I-95 corridor as the night goes on, so there probably will be some showers, maybe a couple of bursts of moderate rain throughout the overnight, but the core of the heavier rain during the overnight should stay to the west. But then as we head into Friday morning and into Friday afternoon, there might be another batch or two of heavy rain as the core of the precipitable water values move over the area on Friday morning, and then a secondary precipitable water max later Friday afternoon. And this is the time period we're going to be watching for heavy rain, downpours, flash flooding, and maybe even some thunderstorms. This is a very classic recipe for heavy rain across the area, and then the parent low pressure gets closer to the area later Friday night into Saturday morning. But at that point, most of the moisture will be leaving the area. There will be enough moisture lingering just ahead of the storm system for some moderate rain to linger throughout Friday night into early Saturday morning. But the core of the moisture with the low-level jet at that point will move offshore. So the heaviest rain looks to be Friday during the day, but then there will be some more rain Friday night into Saturday morning. And then as the surface low moves through our east Saturday morning, cold air comes in behind it. Still a little bit of moisture lingering. So with that cold air coming in at the surface, see these low-level northerly wind barbs, that could lead to a changeover to sleet and some freezing rain before it ends, though of course at this point during the cold side of the storm the moisture is less and the low pressure will be moving away, so there will not be a whole lot of time where the core of the system is juxtaposed with cold air, at least in the immediate I-95 corridor. We'll take a look at the 850 millibar jet on the high resolution NAM model. We see that the core of this jet, which is often where the moisture gets advected most efficiently, as well as where the low-level dynamics are at their core, that the core of the jet is still off to the west. This is now valid at 5 a.m. Friday morning. But then that jet does gradually move eastward as Friday morning progresses, though this would indicate the core of the heavy rain even Friday morning And of course snow further back to the west where it's colder. That would occur to our north and northwest, but still some of that jet does move over the region, so there probably will be some batches of moderate to at times heavy rain, though maybe a little bit more scattered at that point. But then as we head towards Friday afternoon, we see the secondary low-level jet maximum move through, as well as we can even see some of this trough moving east, so you get actually some cold air advection aloft, combined with the core of the low-level jet moving overhead, so you get instability with the cold air advection well aloft, but then warm air advection at the lower parts of the atmosphere, as well as a low-level jet, so you get the dynamics and instability, which lead to potential for thunderstorms and heavy downpours later Friday afternoon into Friday evening. Then that core of the jet moves offshore. There's still some dynamics that linger throughout Friday night into Saturday morning, but again, the core of the low-level jet moves away at that point. And here's the primary storm system approaching the area early Saturday morning, with still some, probably there'll be lingering precipitation behind it. And we'll look at the radar shortly. This is the forecast high-resolution NAM radar. We see that a lot of the heavier rain remains off to the west, but still some rain makes into the area, though I think the main hazard during the overnight and early tomorrow morning will be the fog, as the warm air advection goes on top of the colder snowpack. But then as the day goes on, we see that snow and winter precipitation make it into the Ohio Valley and to parts of the Adirondacks. But here's the core of that heavy rain moving through with that secondary low-level jet maximum. We can even look at a forecast sounding to show what we were describing earlier. We see that 54 degrees at the surface in northeast New Jersey, so certainly a warm surge in the low levels. And actually that warm surge really maximizes aloft. See, there's an inversion, so we're actually warming with height. So at 900 millibars about, the temperatures look to be about 15 Celsius. That's 60, almost 70 degrees at not too far above our heads. But then you get a little bit of that cold air advection aloft from that trough moving in, so you get some elevated instability. So with this elevated instability, these fast wind speed maximums, and that low-level jet we talked about with the dynamics, you can get some heavy rain. Your precipitable water value is 1.6 inches. That's very high for this time of year. And some thunderstorms. So this is definitely a classic sounding for that. It almost looks like an elevated MCS from the summertime. So that rolls through. Then maybe a little bit of a lull in the action when that low-level jet moves away, and then rain will fill back into the area, particularly over Long Island and eastward, because the direct low-level jet with the storm itself, whoops, wrong panel, you see some of those dynamics do try to clip parts of Long Island or get close to it. So there could be a secondary heavy batch over Long Island and points eastward, though this jet does seem to be east of where the simulated radar's heavy rain is, so maybe this range should be further east and the gap in the low would last over Long Island as well. But either way, there probably will be some rain filtering back into the area later Friday night, but not as heavy as that batch on Friday afternoon and Friday evening. And then as the storm gets closer, we see there's an area of surface high pressure, and then the low pressure as well will help to bring in some northerly low-level flow. So the winds in the lower parts of the atmosphere will be northerly, so you'll get cold air at the low levels, but still the warmth remaining in the mid-levels. And that could allow some of the rain to change over to sleet and freezing rain, particularly in the interior before ending. Though, of course, as we mentioned before, the core of the moisture will be moving away, so it may not be that moist, so any wintry precipitation would be very spotty, and not in the form of snow because the mid-levels are so warm. We'll take a look at actually some forecast sounding. We'll look at northern New Jersey. This is now valid at 5 a.m. Saturday morning. We see, look at this mid-level warmth, 900 millibars. We're still about 12, 13 Celsius, so about 60 degrees Fahrenheit. Not too far above our heads, but look at the low-level cold wedge. You're already down to 37 degrees in northern New Jersey at 5 a.m. on Saturday. And of course, still some instability aloft, a little bit drier, these drier patches, because remember the moisture gap that we talked about, so the precipitation will be lighter at this point. But then as we move The next hour is the temperature drops to 33 degrees, so 4-degree drop in 1 hour. The cold surface wedge is getting a lot more impressive, though there's dry air aloft, so again, precipitation does not look to be heavy at this point. And then at 7 a.m. in northern New Jersey, we're already below freezing. So this will be very quick temperature drop throughout Saturday morning into Saturday afternoon. So any standing water would rapidly freeze. And of course, see, we're down to 26 degrees in northern New Jersey at now 9 a.m. But this big warm layer aloft, because of that low-level jet surging and all that warm, moist air, that's going to take a while to erode. We're getting northerly winds at the surface, right? That keeps it cold. But then still aloft, where that warm layer is, the winds are still south and southwesterly. So with that warm layer aloft, you're not going to get snowflakes. Any snow would melt during this warm layer. And then this cold layer may actually get deep enough and strong enough to where instead of freezing rain, it could actually freeze into sleet. So that would actually be good news. Freezing rain is much more treacherous for the roads than sleet is. When this cold layer below is deeper and more impressive, there's time for the raindrop to freeze into an ice particle before hitting the ground. If this cold layer is more shallow, then it won't be able to freeze right away, and it may not freeze until it hits the ground. See, at 7 a.m., the cold layer is a lot more shallow, so at that point you may be getting a little bit of freezing rain, freezing drizzle in northern New Jersey. So we'll have to watch out for that in northern New Jersey and southern New York. But then, about an hour or two later, the cold layer definitely grows in size, so any frozen precipitation at that point would mainly be sleet instead of freezing rain. But still, we'll have to watch out for the trends inland to see and if there will be any glazing of ice. But I think there may be just as much sleet as there would be freezing rain, which may make the roads not as hazardous as they could have been thanks to that cold layer aloft. And now the temperatures are still falling at the surface, even though we are moving into more of the daylight hours on Saturday. On this forecast sounding, we're now at 11 a.m. and it's down to 25 degrees in northern Jersey. That cold layer aloft is finally eroding, but the precipitation is away from the area now. So when the profile finally supports snow, it's dry aloft and the storm has moved away. So we don't really see any snow from the system. And it's going to be primarily a plain rain event. But in the interior on Saturday morning, there probably will be a changeover to freezing rain and some sleet, maybe even more sleet than freezing rain. So, and we can see the storm moving away on Saturday on the NAM model, and of course with a lot of cold air at the lower levels bleeding in, as we saw on that forecast sounding. We can look at a quick animation of the temperatures. We see that on Friday morning and Friday afternoon, we're surging well into the 50s across most of the area. But look at this front, look how strong it is. This Arctic surface high pressure, we're in the teens and below zero in southeast Canada and into the Great Lakes. And this Arctic front marches southeastward. This is now late Friday night into very early Saturday morning. So at 1 a.m. Saturday morning, it's still in the 50s across much of the area. Well northwest, it's down to the 30s and 40s. But then as we now get into 10Z, which is 5 a.m., it's in the 30s, well inland, but still in northern New Jersey and most of New York City, it's well into the 40s. So you wake up Saturday morning, it's still going to be pretty warm, still going to be in the 40s, but then very quickly this cold air marches southward, and we're going to plunge below freezing. So even in areas that don't actually receive any freezing rain or sleet on the tail end of the storm, there will be a flash freeze where temperatures will quickly go from the 40s and 50s to the 20s and 30s in a matter of a few hours. So any standing water will freeze, leading to a flash freeze event. So that could lead to treacherous roadways across much of the area on Saturday morning and Saturday afternoon. And now at this is 3 p.m. Saturday, we're into the 20s across much of the area. Maybe to a peak of around 30, but still, mostly 20s across the area. It's going to be I wouldn't say a shock to the system because we're so used to the cold, but the temperature drop and the gradient with this front is very impressive. So once we get to late Saturday afternoon, Saturday evening, much of northern New Jersey is already down to the teens. So teens to lower 20s, even in the warmer spots, still in the already down to the low 20s later Saturday afternoon into Saturday evening. So it will be a quick temperature drop right back into deep winter, and Saturday night into Sunday morning, widespread teens, maybe even some single digits in parts of the interior. So certainly will be a return to cold, but not after about 2 inches of rain is expected to fall across much of the area. Of course, ending maybe as some sleet or freezing rain well into the interior. I'll quickly talk about the potential snow event for early next week. This is the 500 millibar map on the European model. We see that there's a big P&A ridge spike. This is Sunday morning. So along this big P&A ridge into the EPO region, downstream of that, you get a very strong, potent shortwave diving from Manitoba to the Dakotas and amplifying as it heads southward. And we're seeing a trend for it to actually already cut off aloft, well off to our west. So it's certainly we're seeing stronger trends aloft, with the system increasing the likelihood of a storm occurring. But notice how the trough gets pretty elongated and the core of the mid-level center closing off is actually in the Great Lakes and somewhat dislocated, displaced from the base of the trough. So that could lead to the storm being a little bit disjointed and not truly its own entity. A lot of this vorticity is advecting into areas that already have vorticity. So you're looking more for subtle vorticity advection just due east of the storm, rather than all this vorticity truly being utilized. However, that being said, you still get a very strong shortwave trough amplification as the wavelengths tighten downstream this ridge, and you get due north to south flow with higher heights pulling in over the top, classic for a slow-moving cutoff low. So if this core of the 500 millibar low were to be a little bit further south and more of its own entity, like let's say this vorticity to the north were a little bit less strung out, we'd be getting a classic storm system with a potential blizzard. So we'd really have to monitor that closely. But with the storm not truly being its own entity, it may be a little bit of a late bloomer and also maybe a little bit disjointed. But if you clean up that disjointedness, this has a lot of potential to be a widespread, significant snow event from central New Jersey northeastward and especially into southern New England. But again, with the storm being a little bit disjointed and elongated, that potential may not be realized. But this is certainly an evolution we're going to have to monitor closely. There is a strong model consensus on a large shortwave trough buckling downstream the P&A ridge and tightening and trying to turn negatively tilted as it heads up the east coast. So in the macro sense, there's a lot of good ingredients for a major snowstorm, but the little details may prevent that potential from being realized. Here's the European model at the surface now. We see that as the 500 millibar low approaches the area, see the low pressure is a little bit elongated, a little bit weak, despite the impressive trough aloft, but we do see some low pressure forming off the east coast. Some of that positive vorticity advection does make it at least somewhat to the eastern seaboard, but again, with the vorticity kind of advecting into other areas of vorticity, because it's strung out, you're not necessarily efficiently using this vorticity advection. So if this were to be a little less strung out and the core of the 500 millibar low were to be more towards the base of the trough, you'd be able to advect more vorticity advection and get an explosive setup. And we do see the storms try to explode somewhat as the 500 millibar low goes from positive to negatively tilted. Look at from 132 to 144. The tilt goes from positive to negative as a shortwave trough buckles, and you do get a core vorticity towards the base of the trough as the 500 millibar low finally does move towards the base. If this were to move towards the base of the trough earlier, you'd be getting an explosive coastal system. So that's why I really am intrigued by the ceiling of the setup. But again, with this 500 millibar low initially being displaced from the base, it's a little bit disjointed. But as it does organize, as the base of the 500 millibar low enters the base of the trough, you do get the strong area of vorticity at the base. So you are able to get some positive vorticity advection and a last minute coastal storm development that verbatim gives 1 to 3, 2 to 4 inches for coastal areas, but doesn't really explode until it gets to northern New England. So we'll have to monitor it closely. as it could be an interesting snow event for early to the middle part of next week. But again, there are still some finer details that may prevent the ceiling from being realized. We can look at the jet too on the GFS model. We see that as the storm is still positively tilted, there is some sort of a dual jet where you have the jet at the base of the trough, and there's a left exit region, and then a little bit of a weakening of the jet over our area, which is actually a good thing for snow because it shows that the actual core of the jet streak is both to our south and to our north. See, the colors get darker to our north and to our south. So we're in between these two jet regions, which is often a classic indicator for snow to form in these setups. But again, the storm is still on the GFS pretty positively tilted and somewhat sheared out, so you may not be able to maximize its potential. But again, if it were to consolidate a little bit more and turn maybe neutrally negatively tilted a little bit earlier, we can see that the jet dynamics do support a potent storm system were it to do that. So certainly something to monitor. And the GFS verbatim, it does show some light to moderate snow overspreading much of the area on Tuesday morning into Tuesday afternoon, but with the trough being positively tilted, it doesn't really explode. But still, there is potential for a bigger event, but there also may end up being a lighter to moderate event as if the dynamics don't fully come together. So that about does it for this video. We'll be sure to keep you updated on the heavy rain and thunderstorms for tomorrow. And after tomorrow's storm system clears, we should start to get a better idea on next week's potential snow event. So we hope you enjoyed this video, and we'll talk to you guys soon. Take care.